Alright, the next thing that I want to do is talk about how you would solve this with a calculator. And this particular problem was a non-calculator problem, but these similar types of problems these days are usually calculator problems, and they're usually done with functions that can't be integrated manually. And so I want to talk about how to set them up. The first thing that I would do is would enter the two functions that were given into the y equals, y1 and y2. And you're going to see that when we do that, we will be able to, and go to graph them, you're able to see, although it's kind of difficult to see in that particular graph, you're able to see the picture of what's happening there, which is really the first thing that has to happen. In this case, I would probably zoom in a bit. So I zoom in and enter, and you can see the area in question there. Now, what we normally would need to do with our calculator at this point, although we know the answer to this, is to find the points of intersection. And so I hope you all know how to do that. Second, calc. You see number 5 is intersect. So it asks for the first curve, and notice at the top up here you have this y1 equals x to the third power. So that's the first curve. We just say enter there. Acknowledge that that's the first curve. The second curve is square root of x. We acknowledge that, and they ask you to guess. Now the reason you have to guess is because notice there are 2 points of intersection, and you have to kind of position where you are there. So we know this one is at 0, and we could just hit enter, and it will tell us that the first intersection is at 0, 0. If we're looking for the second intersection, we do the same thing. Second, calc, 5. For intersect, move the curve a little bit over, move the cursor a little bit over. That's the first curve, enter, second curve, enter, and now we're closer to the second point of intersection, so we just have to hit enter again, and it finds the second intersection to be at 1, 1. So oftentimes you're going to graph these two things the way that they should be and find the points of intersection. Now unfortunately the calculator cannot find the area between two curves, so we're not going to be able to use these two graphs to find the area or to find the volumes later on. So we're going to have to go back to y equals, and since we said the area was square root of x minus x to the third, well, rather than type that all in again, what I'm going to do is use y2 minus y1. So I go vars, y vars, function y2 minus vars, y vars, function y1. And I need to turn off the other two graphs. And when I go and graph that, now I can see that that area there, even though it's not the same picture as I was working with before, that is the area I'm looking for. And if I wanted to find the area, I would do second, calc, number 7 for integral. I know that I'm going from 0 to 1. Oops. Upper limit should be 1. Enter. Alright, so I made a mistake. Let's go back. 0 to 1 for the upper limit, and it finds the area to be 0.4166, etc. Now if I want to test that, I can get this, save this. I can hit store, and it puts that answer, and I can store it into variable a, for example, and I can see that it's 0.4166. Now the answer I got was 5/12, so if I wanted to compare those two, I see that 5/12. Now it's not 5/12 is basically the same thing. At least we're accurate to within one, I guess that's 1/1,000,000th of one unit. So that's how I would go about doing that. That's for the area. We'll talk about getting the volume in the next video.